Today, we will take a typical calculus optimization question, but we are going to solve it without using calculus. Here's the question. We are going to find the biggest possible rectangle under the curve y is equal to x cubed. As you can see, we have to have one side on the x-axis and the other side on the line x is equal to 3. And the top left corner has to be on the curve. So how can we do this? Well, let's come up with an equation first. Since the top left corner is on the curve, so this point here is x comma y. That means this distance from here to here is x, and this distance from here to here is y. Then we will have to have the base for this rectangle, and the whole thing is 3. This much is x, so the red part right here is just 3 minus x. So we will just need to find the maximum of the area of the rectangle, which is just 3 minus x times y. And we know y is equal to x to the third power, so we can just plug that in here. Okay, how do we find the maximum of this? And I know many of you guys would like to just distribute the x to the third power and then take the derivative and then set it equal to 0. But the rule for today is that no calculus. So how can we do this? Well, in fact, we have used a similar method before. That's called the AMGM inequality. And for that, remember for AMGM, it depends on how many quantities that we are dealing with. So it looks like we have two quantities, this and that. But no. In fact, I'm going to look at x to the third power as x times x times x, because I want to have just x to the first power. So here we actually have 1, 2, 3, 4 quantities. So for the AMGM inequality, let me put down the 4 quantities version for you guys. So right here, for we have A, B, C, D, if they are all non-negative, then the arithmetic mean, meaning that you just have to add them up and divide it by 4 of them. So A plus B plus C plus D divided by 4, this is guaranteed to be bigger than or equal to. GM stands for geometric mean. You just multiply these 4 quantities, and we take the 4th root. Well, of course, you can also look at this raised to the 1 over 4th power. So it's kind of like the over 4 as well. And then right here, we also have to make sure one thing, because this only gives you the bound. If you look at it backwards, then you can see that this is always going to be smaller or equal to this quantity. But you have to make sure you can actually achieve that in order to be that this is the maximum of this. So I will tell you, for the equality here, we get the equality when we have A is equal to B, it's equal to C, it's equal to D, meaning they are all equal. Okay, so now by the AMGM inequality, so let me just write that down right here for you guys. And one thing to note that though, right here we see that x, well, because we want the x to be in between of 0 to 3, so let me just write this down, since x is between 0 and 3. So that means 3 minus x, well, it will also be non-negative. So let me just write this down real quick. So all these quantities are non-negative. Then we can apply the AMGM inequality. I'm going to multiply them first. So we have 3 minus x times x times x times x. And then we'll take the 4th root of it. This, look at it backwards, it will be less than or equal to. Add them up and then divide it by 4. So we have 3 minus x for the first quantity, plus x plus x plus x, and all divided by 4. Okay, so this is pretty good, but unfortunately, here's a small trouble for it. Have a look. This is always less than or equal to this thing. But if you combine like terms, Minus x and x cancel, so the top is just 3 plus 2x. And then over 4. This is not good, because the right-hand side is still a function. It still varies depending on what x is. That's not what we want. So in order to argue that we will achieve a maximum at some number, this part has to be just a constant. So how can we make that happen though? Well, the idea is that here we have minus x to the first power, and then we have x to the first, x to the first, x to the first, right? We have 3 of the x's to the first power. Let's just divide this by 3, and then this by 3, and this by 3. Because if we do this, all we get is just x. Combined with negative x, they are gone. And then on the right hand side, we'll just get 3 over 4. Now, check this out. Earlier, we took this as A, and then B, and then C, and then D. Right now, what we really need is this being the A, this being the B, this being the C, and this being the D. So all we have to do is come here and then just make the change. Take this for the A, take this for the B, take this for the C, and take this for the D. And as you can see, we still have the same exact idea from that inequality, right? And remember though, we still want to find the maximum of this expression. So let's have a look right here. Now, we just have the fourth root. Multiply them out, we get 3 minus x times x to the third power over 27. And this has to be less than or equal to, now we just have 3 over 4. Okay, let's raise both sides to the fourth power. So this and that cancel. And let's multiply the 27 to both sides. So we have 3 minus x times x to the third power is less than or equal to 27 times 3 over 4 raised to the fourth power. So now we have this expression, which is our area expression. It's less than or equal to this number, no x on the right hand side. And now let's just work that out. And then we can get this being less than or equal to, I will tell you the answer for this, 2187 over 256. I didn't do this in my head. I did this beforehand. And I remember the answer. Yeah. Anyways. So now, this is always less than or equal to this. But remember, once we got an inequality like this, we can only say this is an upper bound of this expression. In order to be sure we have a maximum, we will have to check for the equality here. So I will say for the equality, remember what we said earlier, equality is when A is equal to B is equal to C is equal to D. A, B, C, D. B, C, D, they are all equal, that's clear. So we just have to make sure A is equal to B. So we just need to check when 3 minus x is equal to x over 3. Is this achievable? Sure thing. Multiply both sides by 3. Put this to the other side is 4x and divide both sides by 4. So x is equal to 9 over 4. And you see that x is in between of 0 and 3. That's exactly what we needed over there. So the maximum will be at x equal to 9 over 4. And I will also tell you the maximum area. Just plugging 4 over 9 here and you can get the height and you can compute this. Or it's just right here. 2187 over 256. And that's it.